This is my PDP-1144, and it's a pretty special machine. It is the last non-LSI or large-scale integration PDP that was ever made. Full-on unibus machine with a huge number of cards in it. It uses a ton of AM2901 bit slice ALUs, as well as a legion of 7400 series logic ICs. And it uses so much that the power supply in this thing can supply 5 volts at 120 amps. That's how many ICs it's got to push power through. Now, I'm really excited about getting this machine up and going because I really want to play with some spinning rust. And as far as spinning rust goes, this Fujitsu Eagle is about as cool as it can get. This is a 10.5-inch platter in a full 19-inch rack cabinet package. It's really cool, but I've never had it plugged into a machine, so I need to plug it into this 1144 so we can start stepping the heads around and doing some pretty interesting things with it. But in order to get the 1144 going, we have to get that power supply supplying all of the power that we need. And it's an interesting power supply in that it's kind of 2 power supplies in one. One half of it is supplying plus 5 volts, plus 15 volts, and minus 15 volts for the logic side of things. And that seems to be working totally fine. But the other half of it is supplying a different plus 5 volts, plus 12 volts, and minus 12 volts for the memory side of things. And that side is definitely not working. We were seeing absolutely nothing out of it. And if that side doesn't work, the fans don't spin up and you get a blinking DC on light on the front. And in the previous episode, I had some block diagrams that were really excellent, but they aren't schematics. And so you're kind of limited in how much you can test by using block diagrams alone. And I lamented a bit about this, and you guys are absolute legends. And after that video went live, I got a ton of messages and emails and private messages for people that had links to the schematics. And so thank you all so much. So hopefully with these schematics in hand, we can get the power supply up and going and start trying to incrementally bring this 1144 up. So I am gonna roll the little intro, and while you guys are watching that, I'm gonna pull this out, put it on the desk so we can really dig into it and hopefully get it going. Because everything is so tightly packed into this power supply, and because there's 300 volts DC floating around, this is not exactly a power supply that you can probe while it's on. So we're gonna have to be pretty methodical in figuring out what we want to probe and how we want to probe it. So there's 2 approaches that I want to take while troubleshooting this. The first is actually pretty simple, and it involves this little board here. This board says airflow sensor on the back here, and I can see that the part it plugs into on the motherboard on the bottom there has a pin that is absolutely hammered. So it's possible that this board is causing a problem and preventing the system from bringing up memory voltage. Also, I have no idea what this does. I imagine it's an airflow sensor, since that's so clearly what it says on the back. But I haven't really found any documentation regarding this specific board. The only indication I've seen about what this might be doing is that when you have the backup battery, the memory battery, it plugs into the same socket that this one plugs into, which is why it's got this pass-through connector on it. So potentially this could be sending a signal saying that, hey, a battery's not there, so don't power up or something. I don't think that's the case, but we're gonna inspect that first. Although I'm never that lucky. It's not gonna be as simple as just like leaving this out and turning the switch on and it working. So I'm gonna also think a bit about a different path to troubleshoot, and I think we're gonna do that with this beast right here. Now I have 2 of these, a spare, and I've plugged them both in and they both act the exact same way. We get logic memory, we get logic voltage generation, but no memory voltage generation. And this is strictly for memory voltage generation. I mean, the manual tells me so as well, but also this thing says memory reg and memory inverter on it. So this is all to do with our memory voltage generation, which means that all the signals that I need to check are somewhere on here. And in order to figure out what signals to check, there's this nice little block diagram in the manual here that outlines the entire memory voltage generation circuit. And so I want to check the signals coming into this and the signals crossing from board to board. And I think if I check those, that'll start to give me a bit of an indication of where to focus in further testing. So I think this is going to be several iterations of soldering flying leads, checking stuff, marking things as good or bad, moving further up or down the schematic to find the next potential fault area. So this might be a pretty tedious process, and again, we might hit an IC that needs replacing that I don't have a replacement of, which would be unfortunate, but sometimes that's how these things go. So I am just going to dig right into it, and hopefully we get some good news. Since it's practically impossible and dangerous to get probes down onto the board while powered up, I'm going to solder little flying leads off of the points that I want to check. I just take a piece of wire wrap wire, strip the ends of it, then tack it into place on the through hole or via that I want to check. Then a piece of painter's tape will hold it properly in place so it won't short out on anything. So I know what wire is what. I'll write down what each wire does on a piece of tape, then wrap that around the wire I just soldered up. There's a couple of things that I want to check here, the first being plus 35 volts. 300 volts DC gets converted to AC and then stepped down and re-rectified into 35 volts DC. This 35 volts DC is then used as the main supply voltage that gets regulated down to the three voltages we need, plus 12 volts, minus 12 volts, and plus 5 volts. But if that checks out okay, I'm also soldering leads to MEM DC on, VREF, and sync. Of course, if the 35 volts is no good, all of those will also be totally dead. Once I have all the leads soldered in place, we'll drop the unit back in and give it a test. All right, I've got my automotive light bulb hooked up here to plus 5 volts. That should give us a nice heavy load. I've got the multimeter here hooked up to plus 35 volts over here. It doesn't look like any of these flying leads are touching each other, so we shouldn't have any shorts going on there. I don't know, let's flip it on and see what happens. We'll do breaker on, and then we'll do the switch on the front here. The light did come on, the fans are definitely not spinning, so we still have our plus 12 problem here. And look at that, we are not generating any 35 volts. As a matter of fact, it looks like it's falling. That's really interesting. Okay, so if we're not getting 35 volts, nothing is gonna happen. Okay, things are starting to go a little wonky. Things are breaking and repairing themselves at the same time, and I haven't actually changed anything. All I've done is solder leads on to try and measure what's going on. So the scope probe here is currently on the oscillator output of the 3524. This is the primary oscillator chip that's going to create the oscillations for generating the 35 volts on the memory inverter. So this absolutely has to be oscillating in order to generate 12 volts. But while I was testing this, some interesting things happened. So if I flip the power switch on here, it's now clicking. My 5 volts is dead. You can see that my light here is off, but the fans are now moving and I've got some oscillations going on here, but I'm not at a proper 12 volts. I'm at 1.3 volts. What is going on? There's all sorts of strange stuff happening and things are breaking and I don't know what's happening anymore. Things are spinning, things are dying. It's all very strange. All right, things are not going well, as is evidenced by the state of chaos on this desk. Man, hooking that scope probe up, something happened and it took down everything. The entire power supply is deader than a doornail now. So what happened? Well, I'm 99% sure that I didn't make any short circuit connections. I've double checked them now that I've got everything removed and it all looks good. There's no shorts going on. But the ground for the IC actually loops into a transformer pin, and I don't think that's the same ground as the actual chassis. I think that's a completely different ground, because whenever I had the scope probe hooked up, it was trying to start the 12 volts. And the only thing that I can think of is that we were backfeeding an AC signal into the memory voltage generation and started trying to kickstart the 12 volt system off. But this was causing a backfeed into multiple other places that ended up frying something. So now the thing is totally dead and I don't really know where to go from here. So I just took it apart because I was really frustrated and angry at it, and well, here we are. Before I did take it apart, I replaced as many modules as I could. I have replacements for pretty much every module in here. I dug through my stash and found some more, and no difference. So either whatever fault is going on was blowing new modules as I was swapping them in, or we have a fault on the motherboard itself, which is right here. So I've pulled the motherboard out. I'm gonna start trying to probe things and just make sure that nothing looks absolutely catastrophic. Also, by having it out here, I can disconnect and check all of the large diodes on the output. So I'm gonna go through and just probe and check things, listen to a little bit of heavy metal, and hopefully we can find some smoking gun. All right, I think I may have come across something. I checked as much as I could on the motherboard and it all looks fine. Even the capacitors here actually measure pretty close to within spec using just this and in circuit. So nothing shorted, all of the resistors are bang on perfect. Even all of the diodes show up as actually doing diodes on the motherboard here. So I started checking other things, and there are 4 massive diodes on this huge heatsink back here. And something is a little hinky here. Let's take this one over here, for example. If I hook that up, you can see that we have nothing in that direction. But if I flip it around, we can see that we get 0.16 volts or something like that. And the rest of them check out very similar to that, except for this one on the end here. If I check it, I get 0.001 volts, 0.01 volts. And if I do it in the opposite direction here, again, 0.001 volts. So I'm pretty sure that this diode is hosed. And that's probably not what's causing our 12 volts to not come up, but that could be what's causing our 5 volts to not come up. So that diode's got to come out, but at least we're starting to identify some problems, it looks like. Here is the offending diode, and if we check it with our multimeter here, it's 0.002, and if I check it in the opposite direction, yeah, so that one's clearly shorted internally and I need a replacement, and I was really worried about where to find a replacement for one of these, but Mitch, being a legend, had an insane amount of spares, and he just so happened to have a spare diode in there. So if we check this one, we can see that in this direction we get 0.173, and if we flip it around, we get nothing. So this one is still a diode, and I think that'll get us back up and going. All right, it's all back together. Man, I'm just hoping to get back to where we were at the beginning of the episode. I just want to see the 5-volt rail come up, this little light to come on, and at least get back to where we were. All right, so I've got the breaker on. We'll go ahead and flip the switch on the front here. Yeah, all right. The light came on, 5.3 volts. We're a little high, but I've got the boards all swapped around, and one of the other boards might be a little more stable on that 5 volts, but at least we have 5-volt generation back, man. Oh, good Lord. All right, with the scope probe attached to chip ground and not chassis ground, that's what caused all of our problems. So I've got the scope probe hooked up to chassis ground now, and I think it's gonna work. And I discovered something interesting. We're measuring on pin 14 here out of the 3524. This is the oscillator that starts the memory voltage regulation. And pin 14 is our oscillated output that should be going and firing everything up. So if I flip the switch on, watch this. Did you see it? All right, let's see if we can get a trigger on it here. Check it out. We're getting a single shot on this, and it looks really kind of strange right here, but we can see the oscillator starting up. So I think our memory voltage regulation is mostly good. It's trying to start, but something else is shutting it down the moment it fires up. But the PWM and the oscillator all seems to be trying to do what it's supposed to do. Wait. I think I'm starting to get lost in the sauce here. I was so keen on figuring out what was going on inside this power supply because it was such a weird, unique power supply that I forgot to check the obvious. This is something I probably should have done from the get-go. This capacitor is the primary smoothing capacitor on the 35 volt rail, and it definitely needed a little help to get kickstarted. My bench supply here goes up to 30 volts, so I can charge and discharge this cap manually to reform it a bit. At first, at any voltage above 20 volts, it was taking like 500 milliamps of current to charge up. But after about 10 minutes of working it, that came all the way down to 50 milliamps. And after about another 30 minutes of working with the cap, that came all the way down to less than 10 milliamps. It's not perfect, but the capacitor is getting much closer to being in proper shape. Out of curiosity, I decided to check the other capacitor on the spare module I had, and it's completely shorted inside. The bench supply is current limiting here, but I imagine if I let it run away, we'd end up with a nice, pretty light and smoke show. All right, after a little capacitor reforming, let's give it another shot. I am skeptical that that was the actual problem, but hey, if it is, that's a win. We'll do breaker on here, and then switch on. Nope. We do have our 5 volts, but same problem on the 12 volt rail. It tried to start, didn't happen. All right, I just about exhausted every other possibility. I hunted through and checked almost every single component, and even though this cap looks like it's reforming well, when I check it on the multimeter, it shows that it's about 3,300 microfarad and it's supposed to be 5,000 microfarad. And I don't know, just for sanity's sake, I decided to replace it. Now, finding a Mallory cap like this that you can replace is not easy. So I made a new one. I had some 50 volt, 3,300 microfarad caps. I put 2 of them in parallel, which should give us 6,600. It's a little much, but it's a smoothing cap, so it should hopefully be all right. So what are we hoping for? Well, we're hoping that I didn't kill the 5 volt rail in the process, and we're hoping to hear some fans spin up. So let's flip some switches here. We've got the breaker on here. I'll flip the switch on the front. Fans are spinning. Oh my Lord, it's so loud. Okay. Our 12 volt rail is definitely too low. It says 2.8 volts, but boy, we got fans going at least. Holy cow. All right, let's check the minus 12 volt rail here. Minus 12 volt is good. So we have a good minus 12 volts. But we have a good 5 volt rail. All right, so we've got 2 out of the 3 memory voltage rails. That's excellent news. We're getting there. We're getting there slowly. All right, we're almost there, and in hindsight, it seems obvious. There's this huge capacitor, we should pull it out and replace it, because replace all the capacitors. But you guys know me, I don't like just replacing random components because they can go bad. I want to know what went bad and why. And if I can pinpoint it to a specific capacitor, I have absolutely no qualms about replacing that specific capacitor. So that was what I spent the last 3 days doing, was trying to figure out exactly what was going on. Well, I spent part of that trying to recover the mistakes that I had made that had broken stuff. So thankfully I had a spare one of those, so I got the spare in there and we got back to where we were, but we still didn't have any memory voltage generation. And so that required digging in quite heavily to the schematic here. And I started to understand what's going on here. So the heart of this is a 3524 integrated circuit. This is a regulating pulse width modulator. And if we look at the block diagram down here, pins 6 and 7 go to a resistor and a capacitor to create an RC circuit so that the oscillator can oscillate. Pin 3 I could see was properly oscillating. And then I moved over to the right here checking pin 1 and pin 2 because these are the inputs to the error amplifier. And if these go wonky, that could also cause the problem that we're seeing. And the 2 Zener diodes here are suspect because Zener diodes can fail in a multitude of ways. And so I decided to check the voltage across those Zener diodes. And they are 2 24 volt Zener diodes in series, so they should break down at 48 volts. And I wanted to see if they were breaking down earlier than that. So after taking a scope shot of that, I could see that they were breaking down appropriately at 48 volts, but we should not be getting a spike of 48 volts on here. And clearly the scope was showing that we were. So that meant that our 35 volt generation was doing something really strange. And we kind of knew that our 35 volt generation was a problem from the go because we didn't have 35 volts. And without that, nothing was happening. But the scope showed that we actually did have 35 volts. And then we shot right past it up to 48 volts. And it was an absolute nightmare. It was a total wreck. There was tons of noise and all sorts of stuff. And that's what prompted me to try and reform the capacitor. And reforming it, it actually looked like it was gonna be okay, but clearly it was not. So when I replaced the C28, hooray, the whole thing came back to life. Almost. We have a good minus 12 volt rail. We have a good plus 5 volt rail for memory generation, but we're still missing a plus 12 volt rail on our memory generation. And if there's no load on it, it will kind of float up to about 2.5 volts. But as soon as I put a load on it, it comes right down to 0 volts. So I think we have a fault somewhere in this area. Maybe the 555 isn't working correctly, or we have a bad diode, or maybe even the 3904 is no good and that's not allowing voltage to pass through our pass transistor up there. Something is wonky, and that's going to require pulling this whole unit back out again and attaching more flying leads to it and probing around. But I think that's something that I'll save for the next episode. This is, in my book, an absolute victory, because if I flip this switch right here, we get a cacophony of noise as all 3 of those fans spin up, and we get 5 out of our 6 voltage rails. That 6th rail is still a little elusive, but I think we're going to get that sorted in the next episode, and maybe we'll plug some cards into it in a terminal and see if we can get into ODT or something like that. So I want to thank you all so much for watching, and I hope to see you in the next episode. What we're hoping for is this light to come on, the 5 volt rail to come up, and just essentially to get to where we were at the start. So we'll flip the breaker on here, and I'll flip the main power switch on here. Totally dead. Completely dead.